All right, muchachos, we're going to wrap up our section on unions by doing these last 3 practice problems, all right? So 5.02 to 5.04. So let's just get started. I have them all opened up in Racket. So let's start with 5.02, broadcast status. So there are 2 subproblems here, problem A and problem B. Let's just get started with problem A, all right? Give myself some space here. So problem A, you are designing a program to track a rocket's journey as it descends 100 kilometers to Earth. You're only interested in the descent from 100 kilometers to touchdown. Once the rocket has landed, it is done. Given the data definition for rocket descent, so here it is, right? It's either a number, which is the kilometers, or false, which means that it's already landed, right? Finish writing the template for the function, all right? So that was the interpretation. So, anywho, the first 3 steps of the design recipe are done for data. Just finish the last step for writing a template that processes this data, right? What is the fundamental outline of the function that must sort of happen because of the data definition, right? So anywho, pause the video and try to work through the solution on your own. We'll go spoilers in 3, 2, and 1. Alrighty, so I'm assuming that you guys took a good swing at it. So we need to define a function template, so rd temp, and it's going to assume an rd. So I'm just taking the first r and the d from this case definition, the capital letters from this data def. All right. And we have 2 branches. So this problem is phrased in a one of, and we have to type in a cond with 2 branches matching the amount of cases in the data definition, right? The subtypes. All right. So now we need to ask who you are, all right, and then what you are, all right? And again, the reason we're doing this is because we don't want to pass in the false into, the function for equals, because equals requires all its arguments to be numbers, right? And we don't want to do something like this because it's going to crash the program. So we have to ask who you are and then branch off that, right? Likewise, we don't want to do it the other way either, where we ask, is this false equal to 3, right? It's just going to crash. Again, we just want to ask who you are like this. Is the number 4 Boolean false? And then, not run this function because this doesn't crash. This produces a Boolean and this does crash. All right. So we don't want it to crash. So anywho, let's just do that now. So let's see for the number case and number, So is this rocket descent a number? All right. If it is it in the range of, let's see, 0 exclusive and 100 inclusive. So x 100. All right, did I get that right? Yes, I think I did. All right. And let's see, we gotta do something to this rocket descent. We gotta do something in this case. So let's just do ... rd, because we probably have to do something to this number that we're given in, right? For the rocket descent. Next is the second case. So we could do the who you are and what you are. But since this is the last case, we can do else, right? So whatever this last case is, it has to be a Boolean, all right? Else we want to do something. We don't know what that is yet because it's just a template. But anywho, that is pretty much done. There we go. All right, so let's just move on to problem B. All right, so it's a design a function that will output the rocket's remaining descent distance in a short string that can be broadcasted on Twitter, all right? When the descent is over, the message should be, the rocket has landed. Otherwise, produce a message that says, altitude is number KMS. Call your function broadcast status, all right? So we're going to do these 4 steps of the design recipe. Pause the video and try to work through the solution on your own. I'm going to go over spoilers in 3, 2, and 1. All right. So signature is going to be broadcast status. All right. And what is it going to consume? It's going to consume a rocket descent. All right. How did I know that? Well, it's designed a function that will output the rocket's remaining descent distance in a short string that can be broadcasted on Twitter. So in order to broadcast it, we have to be given it. So that's the first. We have to take it in, right, as a parameter. And what are we producing? Well, we're producing messages, and they are strings, right? This is the message if it's over, and this is if it's still in the air, right? So there we go. All right, purpose statement. It's kind of already encoded in this problem statement here, but always good to write it down to sort of keep relationships straight in your head. All right, so produce the string this. All right, when in the air and that. Go when it has landed. All right, there we go. So that is the signature, the purpose. Next is the stub. Define, let's see, broadcast status RD. Produce an empty string for the stub. Next, let's just write some examples. So let's see, broadcast status. So do 0 exclusive. So that should produce, let's see, otherwise produce message. All right, so it's not over yet because 0, actually 0 isn't even part of this number set, right? Because this number is between 0 to 100, 0 exclusive. So it's never going to be 0, right? We're trying to guarantee that we're never going to be given 0. So that's just invalid. So 1, if it's 1, then we have to put, let's see, the rocket has landed, right? We're assuming actually that no one's going to give a 0. Of course, anyone can pass 0, right? But nonetheless. All right, so when given 1, whoops, I meant we need to put in the altitude. All right, we're saying, let's see, the altitude is 1. All right, let's do another test. Let's do it at 100. Let's do it at 50. All right, and we can sort of see the changing argument here. So we're going to be probably appending strings. All right, and 100 is inclusive, so that is also included here. All right, there we go. Okay. All right, so also we have to test for the false case. So this case right here. All right, so let's just do that. So what if the rocket descent is false? Well, that represents that it has landed. So we just need that stringerino. There we go. Okie dokie. So let's just run, make sure all these tests fail. And now we have, oh, I gotta change this to RD. Habit of writing X, because it has to point to this, it has to reference this parameter, or else X is not a variable that's defined anywhere. So there we go. So now we go and run this. Whoops. And good. Failing tests, but at least they're failing. So now we have a goal to work towards. All right. So now let's just move on to the next step. So let me just mark myself done for these steps. There we go. So next we got to get the template. So let's just use this template as a starting point. And I'm going to delete the stub now. All right. All right. So we're going to call this broadcast status. All right. So what do we want to do here? Now this should be where you pause. This should be all the mental scaffolding needed to solve the problem. Try to work through the solution on your own. I'm going to go with spoilers in 3, 2, and 1. All right. So in the number case, we just got to append, string append. All right. This RD is going to be a number, 0 exclusive to 100 inclusive, right? So it's going to be either 50, 199, etc. So we got to turn this number into a string. That much we know. String. There we go. I'm going to put this on a separate line so we can easily see the, what is it? The condition and then the branch case. So there we go. So the altitude is space. There we go. We just write that string there. All right. And then the number itself, and then a period, KMS, space KMS, and then a period at the end. All right. And we hit append. There we go. All right. So this space is for the number, right? And then this space is for it afterwards. All right, cool. That matches up just fine. All right, so that's the first case done. Let's move on to the second case. So the second case is what happens if it's landed? Well, we just need to produce the string. And there we go. We'll put this on another line just to be stylistically consistent with, condition. And then case itself. There we go. All right, so now we run, all the tests should pass, and so they do. All right. All right, so let's just mark ourselves done for all the other steps. So let's see, we took the template from the d.def, we're done, coded the body done, test review and refactor. We're doing that right now, so I'm Control I to make sure everything's reindented. And yeah, looks about good to me, but let's do a little thought experiment here and just let it diverge. So this problem statement, this data definition states that the number that we're given is restricted to 0 to 100, right? 0, we're excluding 0 and we're including 100. But let's just imagine that someone violates this sort of signature, right? This sort of restriction, right? What happens if someone passes 0? Well, we can just do that right now. Let's just call this function with 0. And there we go. And it says the rocket has landed. All right, that makes sense because 0, right? If we pass in 0, is 0 greater than 0? No, it's false. So this becomes false. This whole and needs all the arguments to be true, but there's one false here. So this becomes false. So therefore, this branch doesn't run. And we're on to this else case, right? And it says the rocket has landed, which makes sense because if you're 0, if you're 0 steps to your destination, you're pretty much there, right? Likewise, though, if you didn't write this else here and you did boolean, RD, right? So there we go. This would crash on this case, right? In fact, let me show you. So there you go. Control P to bring up the previous command. There we go. So this is con, all questions are false, right? So this branch didn't run, right? Because 0 is not greater than 0. So this and is false, doesn't run. And is 0 a Boolean? No, it's not a Boolean. So this is also false. And there are no more branches, and therefore Racket says, hey, all of these are false, right? So something went wrong. This is also a valid solution to the problem, right? Because we're saying here that no one should ever pass into 0. And really that's up in the air, right? What happens if you do pass in 0, right? Let's say someone uses this function in their program. Yeah, right? What do you want to do in the case of 0? Well, that's for you to decide. There's no really clear-cut answers here. You could produce a crash and be like, hey, other programmer who's using this, why are you passing 0s? This is where it crashed, right? That's a valid solution to this problem. Likewise, you can also just default and be like, all right, here you go, right? If you pass in 0, we're going to assume you're there, right? So either solution is valid, right? Either way is valid. It just depends on the project specification as to what you want to do, all right? But anywho, this is as simplified as we can get it. I could remove, these checks, but, I'm just not going to do it because I don't want 0 to be like, hey, altitude is 0 kilometers. Because imagine your GPS, right? Your car GPS saying, hey, you are 0 kilometers to your destination. Why don't you just say I'm there, right? So yeah. So I'm just going to leave this as is. This is as simplified as I can get it. And let me see, submit this to broadcast status. Make sure we passed all the server-side tests. So there we go. And so we do, 3 out of 3. All right. So now let's move on to 5.03, can walk. All right, so this problem has 2 subproblems, problem A and problem B. All right, so let's just get started with problem A. I'm going to give myself some space here. All right, so there's a video here that we should watch. So I'm just going to go here and open it in a new tab. So there we go. So it's just a pedestrian traffic light that I'm pretty sure most of you guys have seen in your lifetime, where it's like a stop and then the walking man and then, a countdown from 10 to 0. All right, that's what we're going to be modeling in this program. All right, we're going to be simulating this traffic light behavior, this walk light, right? So it can walk. So a pedestrian walk light has 3 stages. Walk down from 10 to 0. That's, the most common ones in my neighborhood. It's like 10 to 0. It's not like 21 like in this one. All right. Actually, I wonder if this can go to 99 because there are room for the 2 numbers. That's insane. I've never seen a 99. That'd be interesting. All right. Anywho, so the countdown, right? And then walk, right? So the walking guy and then stop, right? The hand, right? So those are the 3 stages it can be in. Write the data definition for walk light that represents these 3 states using at least 2 types, right? So pause the video and try to work it on your own. Again, just a reminder, the data definition is just a comment like so to model the data we want to represent as information and interpret back out as data, right? So just these steps right here. All right, anywho, pause the video and try to work through the solution on your own. We'll go over spoilers in 3, 2, and 1. All right, so let's start with the data description. All right, so a walk light is one of, all right, so it's either going to be a number, right, because the countdown is 10 to 0. So it's going to be a number from, let's just write it here, 0 to 10, including both ends, right, including 0 and 10. All right, next is the walk and stop states. So we'll say walk, the string walk, to represent that, you can walk, and then the string stop for the stop hand, right? All right, so that's done. Next is the interpretation. So let me just check myself off for the data description. Interpretation, it's kind of pretty self-explanatory, right? A number, and then, walk and stop. So I'm just gonna say it's self-explanatory there. Data examples. So let's come up with some constants, right? So let me see. So let's illustrate this. I'll say walk. The variable walk is just the string walk, all right? And same for stop, right? Just to prevent typos, we use variable names instead of strings. All right, let's come up with some examples for the numbers. So we'll say, define, say n1, is like 4, right? It's kind of self-explanatory for what these numbers are. They're just numbers. We could do the intervals like 0 and 10, but give or take, that's pretty much done. All right, so now let's write a template that processes this data. All right, so let's see. So pause the video and try to work it on your own, right? What is the inherent structure of the function that must be sort of in the function because of this data definition, right? So pause the video and try to work through it on your own. I'm gonna go with spoilers in 3, 2, and 1. All right, so I'm gonna find walk light temp, and it's gonna take in a WL, is what I'm gonna name it. And it's a one of, phrased in a one of. So we need to make a decision between 3 cases. All right, so 1, 2, 3 cases in the data definition. And therefore we need 3 cases in the function definition, right, the cond. All right, so let's start with number. All right, so what happens if this is a number? So we gotta ask who you are for all these cases. So a number, WL, and this number has to be between, let's see, what is it? 0 inclusive, there we go. And then it has to be less than 10, right? So we're gonna say is the WL less than 10. Wait, that's less than, there we go. All right, so is X, oops, that's a typo right there. WL, all right, if so, we want to do something, right? And this may be, triggering some simplifications in your head, right? Like, why would this ever be -1, right? Or something. And, that's a hint to sort of remove this and simplify this right now. But, we just do this very mechanically, not thinking at all. And it's easier to get to, complicated, not complicated, but verbose to simplified rather than the other way around in a way. Right? Because, you always start off a little bit verbose, and then you sort of distill things down as you see patterns and things that you can remove. All right? So next is the second case. So let's see, we're going to ask who you are, because next is the string, and then WL. So there we go. That's the who you are. And then what are you? Are you the string walk? So string equal, So is the WL, the walk light that we're given, is that walk, all right? So I'm just going to use this constant variable over here, all right? If so, we want to do something. We don't know what that is yet. And we can do this last case right here. We could do an else here, all right? But again, I'm just going to be a little bit more verbose, and we'll simplify this a little later, all right? So if this is stop, all right? So there we go. Okay, and later on in the course, we're going to write a visual simulation using graphics for this, which is going to be pretty neat after this section of unions, all right? So anywho, this is pretty much it, and we are done with the data design, all right? So now let's move on to problem B. All right, so problem B. A city has hired you to detect when a walk light is walkable, so it can play a walk sound to help the blind, right? You know, the thing that says go, go, or, you know, something like that, or like walk, walk, right? That voice is for people who are blind and, you know, probably, you know, visually impaired. So you are tasked with the detection only, right? So design a function called canWalkHuh that consumes a walk light and produces whether the pedestrian can walk across or not, all right? So pause the video. We're going to do this half of the design recipe and try to work through the solution on your own. We'll go over spoilers in 3, 2, and 1. All right, so let's start as always with the signature. So it's going to be canWalkHuh, and it's going to consume a walk light according to this problem statement and produces whether or not the pedestrian can walk across or not. So you either can walk across or you can't. So that sounds like it's best being a Boolean, all right? So there we go. All right, so next is the purpose statement. So it's kind of pretty self-explanatory from the name of the function, etc. But again, let's just be a little bit more verbose. So it produces true if walkable, all right? If walk light is walkable, all right? All right. So next we're going to design a function called, whoops. That's the purpose, signature purpose next to the stub, my bad. Brain just sort of died out there. So canWalk takes in a walk light and produces a Boolean. So we'll just use false as that dummy value. Okie dokie. Next are some examples. So check expect. So canWalkHuh, what happens if we're given 10? Well, if we're given 10, right? If the walk light is 10, right, then we can still walk, right? So we're going to say true, right? Likewise, if it's 5, we should also produce true. All right. And then likewise, if it is 0, we should still produce true. You can still walk at 0, right? Sort of. I mean, it's still part of, you can still be in the middle or something and, you know, you're like running across. All right. So let's see. Next is what happens if it's walk, right? So it just turned walk. Well, yeah, it's true. So it's a string walk. Oh, whoopsie daisy. So that means it's true. All right. Now we can also use the constant and we defined here, right? Instead of typing out strings, which is always sort of error prone. So walk. All right. And the string stop. There we go. All right, should also not produce true, right? It should be false. You can't walk. All right, so there we go. I'm going to run this and make sure all the tests fails and make sure there are no typos and stuff. Good, they all fail. So now we have a goal to work towards. So anywho, try to pause the video and, you know, work through the solution on your own. I'm going to spoilers in 3, 2, and 1. All right. So I assume that you guys took a good swing at it. So let's just use just check myself off. And there we go. Template from data. Yeah, we can take the template right now and code up the body. So let's just use this as a starting point. I'm going to delete this stub now. There we go. All right, I'm going to rename this canWalk also. There we go. Okie dokie. All right, so now really pause the video. This should be all the mental scaffolding needed to solve the problem. Go over spoilers in 3, 2, and 1. All right, so if it's a number between 0 and 10, yeah, you can still walk. There we go. If it's a number between, it's not a number, if it's a string, and that string is equal to walk, then you can still walk, yeah. But what if it's the stop, right? Well, it's false. Of course, you can still jaywalk, but, you know, this is trying to spit out the walk sound, right? Anywho, if we run this, all the tests should pass, and so they do, all right? Cool, so let me just check these off. So code body, done, test review and refactor, we can do that now. All right, Control I to make sure everything's all spaced out neatly. All right, so we can simplify this a little further. So I'm just gonna make a copy of this function and sort of show you how to simplify this. Try to simplify it on your own before I go over it though, right? All right, so what can we remove? Well, we can remove this check of, you know, what you are for the number case, because what if it's -1? Well, no one should ever pass -1 into this function, right? Because a walk light only goes from 0 to 10. So we can remove this check right here, right? If it's a number, if this walk light is in number form, then you should always be able to walk, right? You can argue that, if it's getting close to 0, it should be a period where you shouldn't walk when it's like 3, right? I guess you can still run across and that'd be still valid, but it depends on the length of, the sidewalk and stuff. But in this case, for this problem specifically, I'm going to say you can still walk as long as there are numbers showing. All right. So that's good. If we run this, all the tests should pass, right? It's still the same function, same behavior, right? So long as, no one passes -1 and stuff. All right. We're just assuming that from the get-go because of the data definition. We're assuming the data definition will enforce that. All right. And let me see for the string case, right? So after this number, so let me scroll up to the data definition. Right after this number, there are no other numbers. There are no other types either, right? There are only 2 types here. This of type number, right? So that's 1. And then of type strings. So that's 2, right? There are 2 strings, but they're both the same type string, right? So there are only 2 cases here. Therefore, we don't really need to check who you are for this number case, right? So delete and delete, right? Let me just, there we go. Right, because what we're trying to prevent here again is we're trying to prevent this. What if WL? So this is the string walk. Remember that. In fact, I'm just going to do that, right? We're trying to prevent this, right? Passing the number 0 to the string equal home function. That's what we're trying to prevent. And since this is the last type, right, there's only a number and a string. Since the number is already covered by this branch, we don't really have to ask who you are, right? The string ha. So we're just left with, hey, are you the string walk or are you the string stop? So we can delete this and here. And it's a lot more simpler code as compared to all these case checks here, right? So can we go even further? So let me just run the test, make sure they still pass. So the behavior is still the same, just a lot shorter code. Yes, we can. So this else case, right? If you're not walk, then you're probably stop, right? The string stop. So there we go. If we run this case, then it's the same behavior. Everything's all good. All right. So this is the most simplified form that you can get. Either way is valid, right? And you eventually learn how to distill things as you program more and more and remove cases that are sort of unneeded for the problem at hand. All right. Anywho, let's just submit this and make sure that we passed all the tests on the server side. So there we go. Everything's all checked. Let's just go to the website. Here we go, hand in. All right, gonna refresh this page. It's probably gonna ask me to log in. So user 2, you, and we got 5 out of 5. All right, so now let's move on to the last problem. All right, so heal 1. So this problem has 2 subproblems, problem A and problem B. Let's just give ourselves some space from problem A. All right, so consider a video game where you need to represent the health of your character. The only thing that matters about their health is if they are dead, which is shockingly poor health, and if they are alive, which is 0 or more extra lives. So to design a data definition called health to represent the health of your character, you must use at least 2 types of data. All right. So pause the video. We're doing these steps of the design recipe for data and try to work through the solution on your own. I'm gonna go with spoilers in 3, 2, and 1. All right. So I'm assuming that you guys took a good swing at it. So let's just do the data description. All right. So let's see. Health. Health is one of. All right. So it's either going to be a number, right? Number seems good to represent more extra lives. So it's going to probably extend towards infinity. So we're not going to write, a range to cap it. All right. And let me see. We have to use another type of data to represent the false case. All right. So the dead case. So we could use false here. You can use the string dead, right? But I'm going to use the Boolean false, right? Either way is fine, right? This problem is really up in the air and trying to push you to make your own choices, right? Because in all the previous problems, we're kind of like slowly giving you the sort of types, right? So this can be a string walk. Arguably, this can be like true or false or something. but arguably we've been giving you the data definitions. You should get slowly more and more used to thinking of, picking your own data types to represent what, and then interpreting them back out, and etc. All right. So you can write dead, you can write false. I'm going to use false right here. It's just my personal choice. There's no right answer here. All right. And again, it's what the problem statement states, right? You have to at least use 2 types of data. And these are the 2 types. Number is one type, false is the other type. All right. So interpretation. So false represents dead, and numbers are the lives left. All right. So those 2 steps are done. Let me just check myself off for that. All right. Next are some data examples. All right. So we could just write, define dead. Define dead as the Boolean false. Right. Therefore, we're giving a meaning to what false is by, assigning it to a variable named dead. All right. And alive, is just a lot of numbers. It's just sort of, A1 is, 3 or something. All right. So there we go. Those are the examples. All right. So a function template that processes this data. All right. So pause the video and try to work through that on your own to your respective data types, or this one I just wrote here. I'm going to go over spoilers in 3, 2, and 1. All right. So we're going to call this health temp, and it's going to consume call it HP. All right. And it's a one of, so we need, branches that match the number of cases. So cond to the number and then the false one. All right. So now we got to ask who you are. So, and number, So if the HP is a number, then what do we want to do, right? And there's no range interval here. So it's just going to be this, right? It doesn't specify, hey, it's going to be like, 0 through 3 or a capped range. So we're just going to say, hey, if you're a number, we're going to do something. All right. We don't know what that is yet. It could be, could be doing something, adding something to HP or something, but we don't know what that is yet. So we're just going to put ... Next is the second case. So what is the who you are for this case? Well, it's a Boolean because the second one is a false. So what if HP is false? Well, we're going to do something. We don't know what that is yet. All right. So that is the basic outline of this function. Things about this function template that must be true based on the structure of the data. So let's just mark ourselves done for that. And let's move on to problem B. So that's problem A done. All right, so problem B. Give myself some space here. All right. So design a function called heal1 that allows you to increase the lives of a character. The function should only increase the lives of a character if the character is not dead. Otherwise, the character remains dead. All right. So let's just follow the how to design functions. So pause the video and try to work through it on your own. I'm gonna go over spoilers in 3, 2, and 1. All right. So what is the signature? Well, it's going to be called heal1, and it's going to consume health and produce, let's see, it's going to produce a number, right? It's going to add 1 to our lives if we, if we have lives, but it's also going to produce false because if it's dead, right? If it's dead, it's going to stay dead. So this function can produce number or, right? We use this pipe symbol to represent or false. And we have a data definition for this already, right? That's what health is. So let's just write health instead, right? That makes more sense. All right, so that's the signature. Next is the purpose. So the problem statement sort of already tells us what we need to do. So anywho, let's just write it down and it'll sort of outline and help us think through the problem. So produce +1 onto health if it is a number, and sort of 2 is a number. Yeah, sure, why not? And stay false otherwise. All right, so this sort of just writing the purpose statement sort of has us thinking through the problem, right? So we can replace this with dead. So produce +1 onto health if it is a number and stated otherwise, all right? So that's sort of making a lot more sense for the purpose statement. But it already gives us insight as to how to write the function, right? So there we go. That's purpose signature, purpose, now is a stub. So heal 1 takes in an HP and then produces another health. We'll just use false for the dummy value right now. All right, next are some examples. So check, expect, heal 1. So we have 0 lives, then we want to add 1 onto 0, right? So it should produce 1, right? What happens if we have, 2 lives? Well, we just want to add, 1 onto that, right? You could write 3 here, right? This is going to evaluate to 3 anyways, but I'm just being a bit more explicit here. And being explicit can help you, sort of figure out what you need to write for this function, right? So those are the 2 cases. Let's do one last case where what happens if you're dead, right? Heal 1. So false is the dead, case. And we want you to stay dead, right? And again, because we define these constants, we can use the variable dead instead to make this a little more sort of read like English, right? Heal 1 of the dead. Well, you can't heal 1 if you're dead, right? That would be revive is probably the term, right? Anywho, those are the examples. Let's just run and make sure that we have the test failing. So false diverse and 1, expected value. Good. So they're all failing. And this one's passing, of course, because we're reducing false. But okay, those are some steps done. So signature purpose step done, examples done. Next is the template. We already have it from data, so let's just take this from data. All right, there we go. I'm going to replace this step now. And going to rename this from heal temp to heal 1. All right, so that is the template step done. Next is to code the body, test review, and refactor, right? So pause the video. This should be all the mental scaffolding needed to solve the problem. I'm going to go with spoilers in 3, 2, and 1. All right, so I'm assuming that you guys took a good swing at it. So heal 1, what happens if it's a number? Well, we just want to add 1 to that number, right? So given the health, right, it's going to be a number, and whatever it is, we're just going to add 1 to it. In fact, there's a shortcut function called add 1 right here that you can pass in without, typing plus and then 1 over here. This is a shortcut, but yeah, I'm just going to be a bit more verbose here. I'm going to add 1 to the health, right? What happens in this case? What happens if you're dead? Well, if you're dead, I'm sorry, but you stay dead, right? You produce false. Just to be sort of more clear on this implementation here. There we go. All right, so we run this. All the tests should pass. All right, so there we go. Actually, I'm just going to mark myself done for that. Code the body, test review, and refactor. We're going to do that now. Control I to make sure it's all spaced out nicely. And so it is. So pause the video and see if you can sort of simplify this before I do. All right, so I'm just going to comment the old implementation out. There is sort of only one simplification that you can do, which is that, hey, there are only 2 subtypes here, right? Number and false. So we can just do else. All right. All right. If there was another type, like, let's say, string for, I don't know, revive, right, or something, then we would have to, sort of put the branch here for it. But these are all the cases, all right? So I'm just going to run. All the tests still pass. Just one last check that we don't have to do, right? This case right here, checking if it's a Boolean or not, because by process of elimination, there's only one last case left. So let's just submit this. There we go. And okay, again, if you use the string, dead, that's also valid, right? To represent dead, like so, that's also valid. But the greater online for the server side, it requires this to be false. But if you're doing it, dead, the string dead, that's also a valid solution, right? It's just, sort of arbitrary decisions that have trade-offs. So let's just do this. Let me refresh and check my score for heal 1, and we should be done with unions. It should get more interesting when we introduce structures and, subtypes of structures on unions. All right, so test score 2 out of 2. All right, and we're done.